Hello, welcome to Unit 3 of Industrial IoT. Concepts here are focused on IoT communication, IoT networking, Part 1, Part 2, Part 3. The concept of focus here is given more on different type of gateways, different type of network arrangements that are being carried out. In an IoT network, in general, we'll be having to see four major elements, including object. If it is considered, it will go for five major elements. It runs as object with certain parameter and unique ID, which will be sent or received or been sensed by a sensor. Sensor stands as the first and major communication block of IoT from their data acquisition system. And from data acquisition systems, we can run through activators and share the same information through gateways. What happens in the gateways at the other end and prior end to the gateway is other end to the gateway will be cloud or data center. The prior end of the gateway will be a simple data acquisition system connection. So we can consider gateways as routers of communication. So in networking part, the major role played by is through the routers. Now in part 1, we can focus on different types of topologies of connection and different type of protocols used at the prior end, means communication between devices and gateway. In part 3, it will be communication between gateway and the cloud. So looking over the first part, these are the different styles. The type of connection in a network is titled as a topology. So we will have different types of topologies available: star, mesh, bus, circular, ring topology, linear topology, hybrid topology. Hybrid topology stands as a mix-up of any two topologies or more topologies. Most popular is hybrid topology, and most feasible will be mesh topology, and most understandable topology will be either tree or star topologies. Most of client server models prefer this star topology, where the information between any client to client will be happening through the server. So when the connection happens and information has to be interchanged between the nodes or connected devices, it will happen through some protocols and communication standards. The very popular known communication standard protocols or communication systems we are using are of two different models: ISO OSI model, then TCP IP model. So the different layer comparisons between the two models are as mentioned. Open system interconnection model run with a 7-layer arrangement, starting from application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical or bit transmission layer. Where in contrast to this, TCP IP model will be having application layer, transport layer, internet layer, and then host link layer or physical layer in simple. So the place where it stands is presentation layer, session layer, and application layer are being clubbed into application layer for TCP IP model. The current trend that is been running in the market is TCP layer. TCP version 6 is been operational. TCP version 4 is also advisable. TCP version 2 was previously used. We rarely find this OSI model, but the involvement of TCP IP or introduction of TCP IP model was from this basic model. So OSI always stands as a base for all the latest different communication models we have. Now if we compare TCP version 4, it will accommodate up to 2 power 32 addresses inside that IP addresses. TCP version 6 will run up to 2 power 64 addressing capacity. So for all 5G communications which are being used nowadays, we are having TCP IP version 6 communication, where we can accommodate more number of IP addresses and we can have communication to any part of the end for interaction between the users. One of the most important protocol that we can find will be transport protocol, which is common in the both sides, TCP model and OSI model. So two major protocol strategies utilized for transport protocol is connection oriented transmission control protocol and user datagram protocol connectionless. Whenever we have to rely on a standard reliable communication which should also have acknowledgement facilities, we are going to prefer for TCP IP model. Whenever we are going to have it for a long communication where there is no conditional flow, we are going to rely on UDP model, where information will be transferred in the form of packets. There is no particular path for UDP model. Any packet could follow any place. Finally, it will reach the destination. So this is the facility with UDP. Both are having their own importance. We can't say like this is good or this is bad. Both are utilized. Our concept, why did we focus on TCP IP model here and UDP, TCP protocol here and UDP protocol is they are going to be utilized in the same way as like we have OSI model and as like we have TCP IP model in our general network discussion. We also have the same level of representation in IoT networks. Here also we'll have some application layer, perception layer. Perception layer will be the purpose done by the transport layer. Then edge layer, then data link layer will be the purpose of the security layer here, where the information can be used for error checking and detection. Different methods which we previously used for data link layer in OSI model, cyclic redundancy, Hamming code, all these can be utilized for the information security here. So what is the function of each layer is as mentioned here. With the help of this combination of layer, a business layer is utilized for cloud management here. Wherever we have data centers, there we can utilize this gateway communication and we can interact with the device as well as the cloud side. The data layer is towards the device operation, where sensing, data acquisition and communication through the gateways happens. So the four major pillars as mentioned: sensing, data acquisition, connectivity and analysis. Analysis happens at the data center, nothing but at the cloud whenever we want. How do we want the information, in what format we want the information, how much part of information, all can be utilized in this analytics. So the four major protocols which are from the four major blocks as mentioned earlier are being carried out here. Now in continuation to this, if we see the different layers, how they communicate with the different layers of other devices, like we can have a communication between device to device, device to gateway, directly device to the data center, gateway to data center or cloud, or communication between different clouds. So four major styles of information exchange in industrial automation level. So how they are going to be arranged is shown here. When a device is communicated with a device, maybe the device is one sensing device to another sensing device, or maybe the device is sensor and actuator, or two different actuators are interfacing through a single sensor. All this communication can be happened wired through Ethernet or by using local internet connections or local wireless facility connections like Bluetooth, Wi-Fi and all are being classified now with the help of special interest group which we have in communication with IEEE standards 802.15.4 for Bluetooth, sorry, one for Bluetooth and IEEE 802.11 for Wi-Fi. All these standards are being given for communications. And for ZigBee we have IEEE 802.15.4. For one it is Bluetooth, for four it is ZigBee, for Wi-Fi. These are all the standards described by the network communication IEEE standard organizations. Then if the information is between device to device, basic level wireless communication protocols could be used. This is from the router prior communication, like device or device to the gateway communication. When suddenly we increase our information exchange between device to a router, the communication goes with Wi-Fi mostly or LPWAN or our general Ethernet connection. Routing will happen here, analyzing the sensor information and routing it to the destination or data center will be carried out. Now from device to data, somewhere our device can go with edge computing at a times. So edge computing means nearby communications. We will use Z wave, ZigBee wave or Bluetooth low energy enable. Then gateway to data. This is the outer side of the router. From the router, it will be transferred to the data center. Here we will use this communication standards called SAS, PAS, infrastructure as a service provider. This will be the strategy here. When it is communication between two different clouds, like I am working on some local cloud or local information from my university, and I want to find the data of my university in a government organization, can I link it up? Means yes, I will be having the major HTTP protocol for operation. If we are working on two different IoT platforms, we can use MQTT for our information. Like we will see all these MQTTs, very rough example like a radio, where information will be released in a form of publishing, and subscriber has to find it anytime and can read the information. So this is called publish subscribe model, and we have other different algorithms also that mention this communication, other different protocols also that mention this communication model between gateway to data and between data center to data center. So the different names that we can futurize here are message queue telemetry transport, advanced message queuing protocol, full duplex communication channel, and XMPP extensible message protocol, then CoAP constrained application protocol, mostly used for multicast operations. When we have for MQTT, basic and standard IoT applications, smart home, smart automation, smart office, smart agriculture, industrial level, we can go for MQTT. For long arrangements which are happening at web services, we are going to prefer for AMQ. Advanced message queuing protocol. This is the other end from the gateway to cloud. Now, prior to gateway to cloud also, we are having some communications, like as mentioned in the previous slides, different technologies and their comparisons, the standards, the speeds. Of course, Wi-Fi will be having a long range communication compared to other two. That will be the concept. The flexibility is more with respect to Wi-Fi. Then, as mentioned, before the gateway, we are going to rely on Wi-Fi, Zigbee or Bluetooth. After gateway to cloud, we are going to rely on these type of protocols. That's the concept here, a comparison between the different protocols. As I mentioned, why we focused on TCP, IDP earlier is, so some of the protocols here are totally connection oriented and few are connectionless. So DDS, device to device service, data to device service. Then security and their information exchange procedures are also mentioned, point to point, client to server, or publish subscribe. So a simple comparison in a clear way. So these are the representation. Now this is what I was focusing. If you mix up all type of protocols where we are going to use, if we consider gateway as the center, prior to this Bluetooth, Wi-Fi, Zigbee, Z-Wave communication may happen. After this, we can have XMPP, MQTT, AMQP communication protocol. So this is a complete set of communication standards. How these sensors are connected based on topologies. Then part 2 describes how these gateway are getting communicated with these device sensors. It is considered as through any of the wireless technology. Then from the gateway, how it is getting connected to the cloud. These are the three parts of network communication models we are going to focus in unit 3. So we'll take a stop there. Remaining parts of different types of cloud structures we can discuss in unit 4. Thank you.